Alright, in today's lesson, we are going to be combining the two main things that we've learned in this electronics unit, which is Ohm's law and resistors in series and parallel, put them together to solve some new problems that we have not actually encountered yet. So, before we get into the new stuff, I want to start by going over some review problems that were from the previous unit. If you notice, these problems, they're set up so that they actually have a circuit. In the previous ones, we were only given, V equals I equals. So you can see that this battery here has 12 kilovolts worth of potential. This resistor here has 125 mega ohms of resistance, and we're trying to find the current. So just if you're trying to read those, same thing, it's just now written out in our circuit diagrams. And so to solve these problems, we'll have to use the Ohm's law triangle, and depending on what we're solving for, we'll cover that up and it'll give us the equation. So for number one, looks like we're solving for I. So to do that, we have to do voltage divided by resistance. We cover up the I, V divided by R. So in this situation here, we're starting with voltage divided by resistance. And in order to find the resistance, we have to just look at this value here, 125 mega ohms. Or to find the voltage, we look at the battery. That's 12 kilovolts. So we have 12. Kilo is times 10 to the third volts divided by 125. Mega is times 10 to the sixth ohms. And if we do that division, we will get the answer. Now, there's a couple ways you could do this. If you type that directly in your calculator, it will give you an answer that is to the negative fifth, which is not one of our prefixes, so you'll have to move that around. If you do it like I'm about to do it, which is the way that I taught you before, where we treat the coefficients as kind of one problem, and then our 10 to the power ofs as the other part of the problem, and then combine the answer at the end, it'll make it a little bit easier. So let's go ahead and do it my way. So we're going to do 12 divided by 125. And that result is going to be multiplied by 10 to the third divided by 10 to the sixth. And so 12 divided by 125, that gives you 0.096. And then 10 to the third divided by 10 to the sixth, that's times 10 to the negative 3, because 3 minus 6 is negative 3. Now, this is fine, so this would be equal to 0.096 milliamps, but a better way to write this would be to move this decimal 3 more places back, so that's going to be going negative 4, negative 5, negative 6, and that would give you then 96 times 10 to the negative 6 power, which is then 96 microamps, which is going to be the better way to write this, because 96, I can understand that. 96 micro, okay, I can compare that to some other micro value. 0.096 milli, that's really hard to compare to 1 milliamp. Like, how does 0.096 compare to 1? It's a lot smaller than it, but how much? Alright, so that's the first one. Let's go ahead and go to the second one here. Second one, we're trying to find what this resistance value is. That means that we're trying to find what R is. So we go up to our triangle. R is equal to V divided by I. So again, V divided by I. And if we fill that in with the values from the problem, we have 15 times 10 to the 6, that's mega volts, divided by 12 times 10 to the negative 3, which is milliamps. Okay, so again, we can kind of break this problem down into the coefficient part and then the power part. So 15 divided by 12 times 10 to the 6th divided by 10 to the negative 3. So 15 divided by 12 is 1.25. And then 10 to the 6 divided by 10 to the negative 3. So 6 minus negative 3 is 6 plus 3. So that would be times 10 to the 9th, which is 1.25 giga ohms. So this resistor, in order to complete this circuit that has 15 megavolts of potential and 12 milliamps of current, would have to be 1.25 giga ohms. All right, and then our last problem here, we're trying to find the battery, which is our voltage. So in order to find voltage, this is the one where we do the multiplication, current times resistance. So for this last problem here, we've got current times resistance. And in this situation, our current is 1 nanoamp. So that's 1 times 10 to the negative 9 amps multiplied by 15 times 10 to the positive 6 ohms. We've got our amps times our ohms. When we multiply the coefficients, we get 15. 1 times 15 is 15. And we multiply our powers, so 10 to the negative 9 times 10 to the 6th would be 10 to the negative 3rd. And the answer for volts, or for voltage, is volts. And so then if we're writing this with the prefix, that would be 15 millivolts. So again, those are just review problems. Those are things that we've done before. They were, on the quiz, but it's something that you're going to have to do again today after you do what we've been doing recently, which is finding the resistors in series and parallel. So let's go ahead. There's just a couple notes for today, and then we really got to get into the examples. So to use Ohm's law with circuits that have resistors in series and parallel, the first thing you need to do is find the equivalent resistance in the circuit. And you're going to do that using your series and your parallel formulas. So after you found the equivalent resistance in the entire circuit, then you can use Ohm's law. And you're going to use that to find the missing value. So if we're looking at example 1 here, you can see that we're trying to find this current. And so in order to do that, we're going to have to use Ohm's law, do voltage divided by resistance. But before we can do that, we have to find what the equivalent resistance is in this circuit here. So first thing I'll do is I will add these resistors in parallel, right? Because we have two different branches that we could be going down. Now, if we're looking at this problem, both of these resistors have a kilo prefix. So we don't actually have to write out all of those zeros. We can actually just write out the number as it is, and then we'll be able to add it to this 80 kilo. And then at the very end, when we use Ohm's law, that's when we can write out all the extra zeros. So to find this, we go 1 over 50, and remember this is K, plus 1 over 100, K, to the power of negative 1. If you do that, you should get a value of 33.33, and it just goes on forever. We're just going to write out 4 decimal places because it's an in-between calculation. And remember, this is in kilo ohms. So the reason that this is in kilo ohms is that these both were in kilo ohms. We didn't write them out as thousands, so this final result then is also in kilo ohms. Right now, in order to find the total resistance in this circuit, we need to add that equivalent resistance to this resistor that's in series, and it has an 80 kilo ohm resistance. So if we add 80 kilo ohms, then you can see we're going to have all this 0.33 still. But then this just becomes 113.333, and then because we're adding kilo ohms to kilo ohms, the result is in kilo ohms. Okay, so that is the equivalent resistance. So that is an in-between calculation that we are going to need to use in order to find what this current is. But to find the current, we need to use Ohm's law. So I is equal to V divided by R, which then if we fill in with our values here, voltage is 8 times 10 to the 6, or 8 megavolts. And then resistance is this 113.333 kilo ohms, 10 to the third. This would be the problem that we would do. Now, for this one here, if you divide this, because it's 8 divided by 113, you're going to get a really small number. And so with this 10 to the positive 6 and this 10 to the 3, it's actually, for this problem, a little bit easier if we just type the real number in the calculator itself. So to do that, we would do 8 and then times 10 to the 6. So that's, remember the decimals here. So 1, 2, 3, 4, 5, 6. So when we move that decimal, 1, 2, 3, 4, 5, 6, it's 8 million. And then divide that by this 113 times 10 to the third, or 113, and then move this decimal 1, 2, 3. Oops. 3.3. Then we can just type this directly in the calculator and get the answer of 70.6 amps. Now, if you did it like this, what you would end up getting is 0.0706 times 10 to the third power, because 6 minus 3 is 3, and 0.07 kilo. So 0.07 kilo, well, that's okay, but 0.07, what is that? So if we move this back 1, 2, 3 here, like we would have to do to convert this back to the standard, that would give us the 70.6 regular ohms. So again, either way you do, not ohms, sorry, amps. Either way you do this, you get the same answer. It's just, it's written differently. Okay, so let's go ahead and move on to number 2. And number 2, again, first step is finding the resistance in the circuit, and then we can use Ohm's law. So to find the resistance in the circuit here, we've got to first add these 3 in series. So we've got this 5 ohm resistor, this 6 ohm resistor, and this 7, and they're not ohm, they're mega ohm resistors. So 5 plus 6 plus 7 would give us 18 mega ohms of resistance up here. So in order to find what the equivalent resistance across here is, which is the only resistor in this circuit, we have to do our parallel formula. So 1 over the 18 plus 1 over the 8. Take that to the power of -1, and that would give us an answer of 5.538, and it's 4/6, but we'll just round that to 5, and that's mega ohms. Now, if we're trying to find voltage, voltage is current times resistance. So we've got 10 microamps, so that's 10 times 10 to the -6 amps, multiplied by this 5.5385 times 10 to the +6 ohms. Now, because we're multiplying, we can just cancel out the 10 to the -6 times 10 to the +6, because that just equals 1. And then we have to do 10 times 5.5385, which would just be 55 .385, geez, 385, which would just equal 55.3 0.4 ohms. Okay, not too bad. Just had to remember that if they're in parallel, you have to add 1 over. If they're in series, you just add them straight up. All right, for this last problem here, this one is a little bit tricky. So the first thing you have to know is this notation. If all of these are R1, then that means they all have the same resistance value. We don't know what it is, but we know that they're all the same. The other thing that we need to recognize is that these are 3 resistors that are in parallel with each other. So if we're doing this and we're trying to find what the equivalent resistance is, the resistance would equal 1 over your R1 plus 1 over another R1 plus 1 over a third R1, and the result of that taken to the power of -1, or taking the inverse of. So if we're writing this out then, so 1 over R1 plus 1 over R1, so they have a common denominator, it's R1, so we can just add the tops. 1 plus 1 plus 1 is 3, divided by, and then we have the common denominator of R1. So 3 divided by R1 to the -1 power is our resistance, which when you take something to the -1 power, you just flip the numerator and the denominator. So the resistance would be equal to R1 divided by 3. Now, how are we going to find what R1 is? Because all we know is that the total resistance is equal to R1 divided by 3. Well, we also know that resistance is equal to voltage divided by current. So in this situation here, we have 12 volts and 1 amp, so our resistance is equal to 12 over 1. Now, you can see that resistance is equal to 12 over 1. Resistance is also equal to R1 over 3. So if we're trying to find what R1 is, we just set these things equal to each other because they're both equal to R. Just 2 different ways of writing it. R1 divided by 3 equals my 12 over 1. And then if you haven't learned about cross multiplication, when you have one fraction equal to another fraction, you can cross multiply and set those things equal. So R1 times 1 is equal to 3 times 12. So R1 is equal to 36. Okay, so those were the example problems there. Hopefully you kind of starting to get this down, starting to understand it. What I'm going to have you do now is try these practice problems. And we will go over these practice problems in Friday's class to make sure that we're all on the same page before we do a little bit more practice on Friday and get into the final part of this unit. See you on Friday.